was the TBM's laser guidance system. Laser guidance is commonly used to keep above-ground structures like roads on course, but underground it had to be used in a more imaginative way. Instead of looking ahead to see where they were going, the tunnellers looked back to where they'd been. Laser beams continually scanned backwards to the tunnel's start point to compare it with the TBM's changing location. Computers then checked this data against the surveyor's course coordinates. For tunneller Brendan Riley, the laser guidance system was one of the TBM's most impressive features.
As the machine moves forward, the laser monitors the change in movement to say whether the machine is moving left or right or up or down. With that information fed back into the computer, it compares that information where the TBM should be at that known point in time and gives that information back to the driver to say whether he needs to steer up or steer right.
As the tunnel face moved further from dry land, conditions for the men got worse. Engineering manager Ian Fugeman recalls the scene.
Anybody going to work had to travel in a cramped train up to 22 kilometres out to the place of work.
By the end of the dig, the workers' trains had clocked up enough miles to go to the moon and back 4 times. This far underground, keeping the air fresh is a major challenge. A massive ventilation system pumped air to the tunnel face. But the men still face the risk of encountering toxic gases.
The further in you are, the warmer it gets, the less air. We carried respirators with us. If there was an accident, we'd have enough air to breathe with.
But Chief Engineers Gordon Crichton and Laurent Leblanc, the frontline commanders of the tunnel dig, were starting to breathe easier. The schedule was holding up, and so was the layer of blue chalk. But what happened next came without warning. March 1988. The service tunnel on the British side. Suddenly, what no undersea tunneler ever wants to see. Water. Thousands of gallons of it flooding into the tunnel. Work comes to a halt.
Cause panic. So we have to stop straight away because you don't know exactly what you're going into.
But Gordon Crichton must act fast to find out where the water is coming from. Is this just a random pocket of fresh water? Or is the sea itself breaking through? He tastes the water, and it's salty.
We knew we had a path right to the channel itself. We knew it was serious.
It's disastrous news. What's coming into the tunnel is seawater. The men know that above their heads there's 3,000 billion tons of it. The pressure on the seafloor 50 metres above is enough to crush a car like a beer can. Now, in places, the water starts to burst through with the force of a fire hose, 300 litres a minute. Then, a crack appears in the tunnel roof. Rocks start to fall. The water is pouring through fissures and loosening lumps of the tunnel roof. The British tunnellers might just be on the edge of disaster. If the cracks worsen, they might let in enough water to weaken the tunnel. Ultimately, it might even lead to the tunnellers' biggest fear: collapse. Chief Engineer Crichton must find a way to plug the leaks, or they could face catastrophe. But how could this be happening? An 18-month survey identified the special layer of rock called blue chalk that was meant to be waterproof. But the geologists are quick to point out that surveys based on sound waves can reveal the course of a rock layer, but they can't give a definitive picture of the rock's quality. Now it turns out that the stratum of rock the tunnel is driving through is fractured, riddled with fault lines and cracks, something the surveyors could not have foreseen. Back in the British tunnel, engineer Crichton averts disaster. The men plug the leaks and concrete liners are replaced by stronger cast iron versions. Crisis over for now. The tunnel tigers start to inch forward again. But the fractured ground stretched on, and the atmosphere was edgy.
Every ring that you cut, you were just hoping that it was going to be good ground that was there.
But there were more delays as the leaks short-circuited the TBM's electrics. The clock was ticking. With every day, the costs were mounting. And the overspend was running into tens of millions. The French side, meanwhile, had also hit water.
We did indeed hit water. That made the job more difficult. A lot of water always makes the work harder.
But the French had been forewarned about fractured rock on their side. Features in the geology made it much simpler to analyse. Now the French decision to opt for waterproof tunnel boring machines finally started to pay off. Slower than the British TBMs so far, they now gave the French a serious edge.
We decided to use tunnel boring machines that were totally enclosed, totally watertight. These could resist any level of water leakage, no matter how severe.
Meanwhile, the Brits slogged through the leaks and falling rocks and prayed for better ground. Workers rigged a form of makeshift armour plating on their TBM and pressed on. January 1989. After a tortuous 9 months, the British team finally hit drier ground. Massively behind, the pressure to catch up was now intense.
Everybody worked long hours. We had to do it to the time. We had to do it to the programme.
But at last, the Tigers were smiling.
The ground conditions come right. Everything seemed to fall in place, and then we started taking off.
The British tunnellers fought their way back into the race.
We've done over 400 metres quite a few times in a week. And I personally think we could have done a half kilometre.
But success came with a sting. The British progress started to stretch the supply of lining slabs. If the slabs ran out, their dig would grind to a halt, with a multi-million-pound metre ticking. January 1990. The French and British tunnelling teams were 2 years into digging the record-breaking Channel Tunnel. The competition between the two countries was fierce as they dug out from their coastlines. If all went to plan, the tunnels would meet up some 18 kilometres out, midway under the English Channel. Flood and rock falls on the British side nearly spelt disaster and set progress back weeks. But now the Brits were catching up again, and the race for the halfway point was back on with a vengeance. But there's more to building a tunnel than high-speed digging. Above ground, a huge round-the-clock operation kept the project fed with vital supplies. And the most crucial ingredient of all, concrete. Each slab weighs as much as a pickup truck. The French and the British together need 3/4